Hi and welcome. This is video number 305. In this model, I am going to compare the results of 5 different types of panel analytic models. And these analytic models will include pooled OLS, within regression, between groups, regression, SWAR, that is Swami and Aurora estimator, and maximum likelihood estimates. So these are the 5 models that I'll be discussing. Again, this is some explanation, verbal explanation. Now let me show you. This is the data file that I downloaded from the net, and its source is Granfeld 1959-58 paper, and this is panel data for 10 US firms over 20 years of time period, starting with 1935 through 1954. These are variables: firm number, year, I stands for annual real gross investment, F stands for real value of the firm, and C stands for real value of the capital. Before I show you the actual estimation in the data, I would share excuse me, I will share with you the results of the estimated model that I have already done. So let me start with the pooled estimation technique, and this is the command for pooled estimation technique, reg IFC. So I'm regressing in gross investment, real value of gross investment on firm value and capital stock, and these are the various values. Now I have given the explanation of various variables here. This is R square. Now R square is equal to explained sum of square divided by total sum of square. So this is this one. If you divide by this one, so we get 0.8124, and this is exactly here. Then we have adjusted R square, and the formula for the adjusted R square is 1 minus ms of the residual, that is this, and divided by ms of total. So ms of total is this. So if you do that, we get 0.8105, and we have to subtract that ratio from 1. So that is exactly the same value, 0.8015, and we can calculate that using calculator. MS, this MS means the mean sum of squares, and this is F stat, and F stat formula is explained sum of square divided by k minus 1, that is the number of estimators minus 1, whole divided by residual sum of square divided by n minus k, when a is the number of total observation and k is the number of estimators to parameter. So this divided by this is this, and this divided by this is this, and that is finally equal to 426.58. So we have exactly the same value if you use this formula. This is F is defined as the ratio of the ms of the model to the ms of the residual. So ms of the model is this, and ms of the residual is this. This is ms of the model, this is ms of the residual. So if you divide this by this, we get this f value. We can also get exactly the same value of f statistic if you use this stata command, that is test palm fc and then enter. So we will calculate exactly the same value f. Here is root MSE, and that is the square root of the MS residual. This is the MS residual in the ANOVA table. This is ANOVA table, and that is equal to the square root of 8912.94636, this value. And if you take the square root, then the value is equal to 94.438. Now we should note that root mean square error is the standard error of the residual. This is the between group regression, and the command for the between group regression is xtreg. We will have to declare the data as a panel data and then we will write the dependent variable, then the independent variables f and c, and after comma we will use b. So b is stand for between regression, and between regression means regression on group means. So the total number of observations is 200, number of groups are 10. This is the f state value, and these are the coefficients, and we can compare these coefficients with the other models that we will be estimating. So keep in mind these coefficients and their standard errors. This is the fixed effects are within groups regression, and the command for this one is xt ifc comma fe, and these are the results. Okay, so these results and the previous results are more or less the same, and here is the f state value, that is 309. This f value is greater than the one in the previous model. In the previous model it was 21, but in the within it is 309. This is the SWAR model, and SWAR basically stands for Swami and Arora estimator, and that use random effects using GLS method. GLS stands for generalized least square regression, and the command for this one is xtreg ifc, where I is the dependent variable, f and c are the independent variables. This re stands for random, and theta. When we give this theta command, then it estimates these GLS regression coefficient estimates and standard errors. Now this f is much, there is no f here, but here it is Wald chi-square, and this is much higher, and it is significant. After this, I'm going to show you the random effects model using maximum likelihood estimation, and data is the same panel data. The command for this regression is xtreg ifc comma, and then we write small mle. So mle stands for maximum likelihood estimation. So my dear students, this is how we estimate various models, panel analytic models. Now let me show how we can do that in Stata. So here is my Stata, and I have already done this, and here are my various commands that I am using. So let me exit this. So let me start with the reg, this one. Now here is the pooled OLS regression equation and their estimates that I already explained. This is the coefficient of the f. So it means that keeping real value of capital stock 1 unit increase in the real value of the firm increases investment by this much. So this is the f value, f state. This is the r squared. This is the adjusted r square. And now let me look at this f, which is 426.58, and I told you that by this command I also got exactly the same f value as here. So this is very interesting. After that, I'm using this command. I have already declared this data as a panel data. So now I am using to regress this command, that is xtreg ifc comma and then b. Now this is between groups regression and group means. We also call this between regression, and it means regression and group means. Now here f value is 21.11, and this coefficient is a little bit higher than the pooled OLS1, and this is the constant, and this is the coefficient of value of real value of the capital stock, and here only the coefficient of the real value of the firm is significant, but the real value of the capital stock is not significant. After this, I am going to show how to estimate the fixed effect model, and this is also known as within group regression model. And the command is this: xtreg ifc, comma fe stands for fixed effects. So individual specific effects are assumed to be constant. So in this model, both the coefficients of f and c are significant. The f statistics, the f state value has gone up, and these are r squared within group, between group, and the overall group. And after this, I am going to show how to estimate the SWAR estimates, that is Swami and Arora estimator. So the command for this is this: xtreg ifc re. This is basically random effect model, and this theta means that these value have been estimated by using Swami and Arora method. Again, there is a little bit difference between these coefficients and the other one, but all these coefficients are still significant. After that, I am going to show how can we estimate a random effect model using maximum likelihood estimates. Now the command for that one is xtreg xtreg. I is the dependent variable, f and c are independent variable. Then I will place comma, and after comma I will use MLE, and if I press this, I will get this. Now this model is using iteration. You see, after this command, it fitting constant only model, and these are number of iterations. These are number of iterations. So fitting full model, there are 5 iterations: 0, 1, 2, 3, 4, and number of observation 200, number of groups 10, and these are observation per group, minimum, average, and maximum. This is constant, it's the same. This is Lagrangian chi-square, and these are the coefficients of f and c, their standard errors, their z values, and their p values. Now both these coefficients are significant. Ladies and gentlemen, I hope this is interesting for you, and in the coming model I will show you how can we group or combine all the estimates of the coefficients and their standard errors in one table of these. So I'll do that in another model, so wait for that. Inshallah, tomorrow or the day after tomorrow I'll upload another model regarding this. So you will find how to group various estimates of the coefficients and their standard errors in one table.